Okay, so here we go. Chapter 9, Hypothesis Testing. Essentially, the culmination of many chapters that we've studied together. So, chapter 5, 6, 7, and 8 are all intertwined and build up to this point. So, the idea of a hypothesis test is to essentially set a standard against which we will provide evidence, and if that evidence supersedes the cutoff mark or the level that we've set, then we either reject the status quo or we do not reject it. So what is the status quo? The status quo is called a null hypothesis, and that is the current situation that we're dealing with at the moment. The agreed upon statistic parameter or what is currently being believed is true. So it's a statement about the population parameter. A very key point that I'd like to impress upon you strenuously. In hypothesis testing, we always test the population parameter. We never test anything else. We always make our conclusion against the population parameter. We say we reject the null or we do not reject the null. We never talk about rejecting or accepting the alternative hypothesis. So the alternative hypothesis is essentially the claim, and it is a challenge against the null hypothesis. It includes everything that the null does not. We'll see what that means in one of the problems. Then we talk about significance levels, and we've talked about those many times in chapter 7 and 8. So there are three types of significance levels that we discuss usually in statistical analysis. Alpha, we usually do the 90%, the 95%, and the 99% confidence level or significance levels. We can take any significance levels, but these are the three that are most prevalent. So what is alpha exactly? I said before that we'll talk about it, and here we are. So alpha is essentially a level of error that you as a researcher are willing to accept. So we know that nothing is perfect given the fact that we take a lot of samples in order to draw our conclusions. We know that there will be some level of mistake. So hypothesis testing looks at a procedure in which we have a margin of error or a level of error that we accept. And those mistakes are as follows. There's really two types of mistakes that you can make in hypothesis testing. So they are type 1 and type 2 errors. Obviously, you can also not make an error. So a type 1 error is when you reject something that is actually true. So in the case of a criminal justice system, it's sending someone to jail when in fact they are innocent. So when someone gets accused of a crime, they are innocent until proven guilty. So the status quo is always he is innocent. The alternative, he is not innocent or not equal to innocence. And so if we actually reject his innocence, we reject HO, and he is in fact not guilty, then we've committed what is called a type 1 error. On the other hand, if we do not reject something that is false, we commit a type 2 error. So if somebody is actually guilty, but they walk away for some reason, then we fail to reject the null when it's actually false. We've committed what is called a type 2 error. And it's best illustrated in this little diagram here. It's a 2x2 sort of matrix. When you have on one side you have the true state of nature, the real answer, and here is what the decision looks like. So in the case of a criminal justice system, if someone is innocent and the judge says, I do not reject their innocence, meaning they're confirming the innocence, you essentially have a correct decision. However, if the judge or jury reject the innocence, then we've committed a type 1 error. We've rejected something that is actually true. On the other hand, if they are actually a criminal, but maybe they have a very good lawyer, they are actually guilty of whatever crime they're accused of, but then the judge and jury say, hey, we do not reject their innocence, then we've committed a type 2 error. So in statistics, what we try to do is we try to avoid mostly a type 2 error. Why? Because changing the status quo takes a lot of work. The reason why it's the current situation is because there has been a lot of work done in order to get to this point. Think of a law, for example, how many drafts need to be written, how many arguments need to be presented, how many votes need to be taken in order to adopt and implement a law. One can't just change the law just simply because there is some evidence that it doesn't work. Maybe it's a fluke, maybe it's by luck, maybe it's just a certain circumstance, a special circumstance that has shown evidence that the law doesn't work. But that doesn't mean that everything has to be scrapped. So we do our best to keep the status quo until there is really enough evidence beyond the shadow of the doubt in order to reject it. And in this particular class, we will never be calculating the type 2 error, although it is calculable. It is the opposite of a type 1. So when type 1 gets smaller, this one gets bigger and vice versa. But for the purposes of this class, we won't bother with it. We're going to run 3 types of tests in this chapter: a one-tailed, a two-tailed test, as well as so an upper-tailed one-tailed test and a lower-tailed one-tailed test, as well as two-tailed test. What that means is that sometimes the claim is leaning towards a certain outcome. So for example, let's look at this one-tailed lower test scenario. Let's say there's a clinic and that clinic has a waiting time of 15 minutes before you see a doctor. And then the owner of that clinic all of a sudden comes out and says, oh no, I think that my waiting time, the clinic's waiting time is actually less than 15 minutes. So you'd like to test that claim, and that claim is talking about the less than concept. So we're looking at the left-hand side of the distribution. So we're going to test the lower side of the distribution. And as a little trick, I always tell my students to always pay the most attention, all of the attention, on the sign of the HA. The sign of the HA will tell you what kind of test you're going to run. So for example, let's continue with the clinic example. Same clinic. And it's 15 minutes, and someone says, no, I don't think that the waiting time is 15 minutes. Now notice the phrase, I don't think it's 15 minutes, doesn't really indicate if that person is claiming it's more than or less than 15 minutes. So essentially what that person is saying is that the waiting time is not 15 minutes. When that comes up, that's a two-tailed test. So you want to test on both sides of the distribution. Similarly, we can go and do the last part here. HO mu is equal to 15 minutes. Notice that I always use mu. Mu is always the population parameter. I'm always testing the population parameter, never the claim. So the status quo is that mu is equal to 15, and someone says, you know what, they have terrible service. I think that their waiting time is much greater than 15 minutes. So here the person is claiming that the waiting time is greater than 15 minutes. And so we test the upper tail of that distribution. So those are very key examples of how you can determine which test to run. In terms of the reject and do not reject, we're going to talk about these when we do a problem. We're going to explain what ZX bar is and what Z is, and what it means when we put these brackets around our variable or our normal number. There are 6 steps in order to conduct a hypothesis testing. These I've written a little bit extended. There's actually maybe about 4 steps. We're going to see that when we do the problem. And in terms of formulas that you're going to use, you're going to always use the same ones you've used before in chapter 7 as well as chapter 8. So here you're calculating the Z value, and you're also calculating a T value, and you're also calculating Z when it comes to dealing with a proportion. So all 3 of these formulas are formulas you've seen before, essentially solving for a standard normal number, and according to which state of sample size or distribution shape, we can choose which test or which normal number to take. Finally, there is what is called a p-value approach. So there's two approaches to solving a hypothesis test, one using Z or T, and another one solving for what is called the p-value. Now, I'll work out one of these problems. It's best to see it instead of it being talked about, but the definition of a p-value is the probability of obtaining a test statistic, we'll talk about what this means in just a little bit, of at least as extreme or more extreme than the one we've calculated in our sample. So keep that in mind. We're looking for a probability that is small. The smaller the probability, the smaller what is called the p-value, the more significant the test is. So these are the main highlights of Chapter 9. Really quickly, it's the idea of testing with a standard. We're going to look at a null and an alternate hypothesis. We're going to be given a significance level. That significance level is going to be used when you do a one-tail lower test, a one-tail upper test, as well as a two-tail test. And you can determine which test to use by virtue of understanding what the alternate hypothesis is. Finally, we're going to calculate what is called a p-value, and we're going to conclude.